We're making equipment that manufactures 3D printed electronics, or what we like to call additively manufactured electronics, or AME, that works on printing 3D circuit traces in materials with both a dielectric and a conductive ink. And one of the fantastic things that I know we want to discuss today that I've really been thinking about a lot lately in this technology is truly the revolutionary statement that you made. Is we're trying to take an industry that's in a 2D mindset and move it to a 3D world, and it's very challenging. There's a lot that goes into it, and I'm really happy to discuss that today with you.
So, Sean, we're going to level set our audience. So, printed circuit boards kind of run everything. Everything we do has got a chip in it. It's got a semiconductor in it. Yeah, I think you have one there. Maybe you can hold one up. There you go. So everything is made of these things except for the lettuce at the store. And so, and they're made by, layering things. And there's lots of great technology that has allowed us to do that. To your point, it's all two-dimensional. So when I heard that we've been hearing the last several years about 3D printers, so that's not news anymore. But the idea that you could use the 3D printer to make a new type of circuit, I kind of went like that. And I'm curious, and I want to get to the part about the design thinking, but what is it? What do you think is the power that this unleashes? What's going to change in the way we think about computing?
Yeah. So as you mentioned, this is a printed circuit board. Ironically enough, it's always been called a printed circuit board for 3D printing. And what you also mentioned for education of the audience, those little black things on there with the chips and the semiconductors. The rest of it is actually the PCB itself for the printed circuit board. And so, yeah, it's what our technology and the technology we're focusing really on in the future is going to change how we manufacture electronics and how most people think about 3D printing. Like I can print it now on my desktop and here it is, no different than, the future that you have a printing paper on your desktop and you designed it on your computer, and we want to get to that place, which is all well and fine. And I think it revolutionizes electronic manufacturing in that way, right? Get it on demand, whereas normal lead times for these things, and I used to be in the industry, it can be, if you pay a lot, you could get it in 5 days, but usually 6, 8 weeks, sometimes months, depending on the complexity of the board. It will change how we think about that as the engineers think about it differently. And so it's, yes, we're going to get it tomorrow and it's fast and it's, we can print a circuit board right next to me, but it's about how you can change it. So we mentioned it's 2D, it's effectively taking a piece of paper that has both a top and bottom with these copper lines connecting all these little components on it. And it's been that way since 1950. Right. And so we took a layer, and then later on, as mainly the moon missions have pushed us this way, they say, oh, we need more layers. So they do layer over layer over layer. So 2D over 2D over 2D, and then we connect it with a hole. And it's been done that way forever, and it still is done that way. In the most sophisticated electronics you have, that is how it's been done. And so it's 2.5D light. And so I think engineers will get their products faster, and we will revolutionize the electronics market, because we can start to get into new form factors by printing it in many, many, many layers, like what I just showed, more like 4,000 layers versus sort of 4 layers of what we're kind of discussing. And so it will change how people think about the manufacturing of the electronics. But the real thing is that will revolutionize electronics. But as you blend this electronics with this 3D, it's really mechanical and electrical coming together in sort of this amorphous blob of a new material. Like the blob itself is a material that has both electrical properties and mechanical properties. And that's when the world revolutionizes beyond just electronics, because now it's a new thing. It's a new core base of material. It's not just metal. It's not just some other material. It's not those materials manufactured in separate parts of the world and then assembled together. This is this blob of new stuff. And I think when people get to that and they're designing things with that mindset, we will have things that we haven't even dreamed of in aerospace and defense and medical worlds. Very exciting.
Having been a tool maker my whole life in software tools and doing things that people have never done before, so they've got to invent a new tool to make the thing to do the thing, and all of that with visual effects, I understand the problem. And I think what we've talked about already is that designers are still thinking in the 2D headset.
Sure.
And what what kind of work are you doing, if you will, educating them? And are you working with tool makers to make it easier for them to start thinking? I mean, it feels like there's a pretty big educational
Yeah.
block to roll up the hill.
There is an educational block. The easy elevator pitch is to say we have a machine that prints 3D circuit boards, and people will get that. But the problem is by me just saying that, you're now thinking, okay, I have a circuit board. You can print the circuit board that I designed 20 years ago. Yes, but that's not it. It's about the revolution of that industry.
Right.
And if I can liken it to 3D printing, in the mechanical space, right? We've always designed mechanical, one was back in paper and then eventually became on computers, CAD and all that kind of stuff. But the mindset has always been 3D. If you go back to the books of Leonardo da Vinci and those kind of things, it's always been 3D. And we've always manufactured in 3D through machining and all these various things. And then 3D printing comes along. Well, we've already designed in that way. We're just manufacturing it slightly differently. And it changes some restrictions on design for manufacturing, but that's not revolutionizing the entire thing. It's an evolution of manufacturing. Now take that to the space in electronics, where it's always been 2D on a piece of, you actually used to draw with, and you can go get these kits at home, by the way, off the internet, and you draw with a little pen and you etch away the copper and you have traces that you design on your own instead of using wires. So then the software follows through, and the software is 2D in nature. And that software is taught at universities. That software is then given to companies. And so it becomes, the design is always in that 2D. And now over the course of history, manufacturing in many, many areas used to be with the original equipment manufacturers, OEMs, right? A company designs a product and they manufacture that product. But as things get bigger and more complex, you start to move this out to companies that just focus on the manufacturing, or called contract manufacturers, right? They manufacture based on the design that you give me. So the big companies that we all know of today don't actually manufacture anything. They assemble in some cases, but they're really not manufacturing. They order from somebody. So now you start to diverge the design from the manufacturers. And so manufacturers only support themselves for the designs they're given, right? So I now in the electronics world, I'm having 2D designs. I'm ordering from the manufacturers. My demand as a manufacturer is a 2D design. So I'm going to manufacture it in 2D. The equipment that I buy in my own manufacturing processes supports 2D manufacturing. And so then I update the design rules into the 2D softwares that the engineers then use on their next design. And you have this negative virtuous cycle going on. And so it becomes a revolution in the electronics industry to truly change that mindset. And so we are working with upfront the designers of the electronic tools to get to to really mechanical CAD programs that, there's famous names out there. And we are adding electronic packages or plugins to those. And we're also meeting other, design firms halfway on where we kind of meld those together. Then you have to take that to the universities to get the young engineers thinking and excited about this stuff. And then you have to wait for them to go in to get into a position of authority,
get a job,
get into that position of authority where now you can go and say, I'm going to buy these large pieces of capital equipment in order to make these designs that I dreamed of back in college and as a young engineer here, but now I'm in, an institutionalized engineering firm, and I'm kind of bucking trends here, trying to say, no, do this. And they're like, who's going to manufacture it? Well, they don't have that yet, right? So it's this revolution of the entire supply chain. So it starts with that, that design software. It starts with the education of engineers, and then you have to go find those creative companies. And then eventually that flywheel starts to pick up, the design comes, manufacturing gets better, and then you start to really get to that space where it's not just, it becomes an art. Manufacturing of electronics and mechanical together becomes an art. Engineers right now in that space are not artists. They don't, because they're confined to the digital environments that have been created, right? So
they will be.
They will be.
I'm loving hearing the strategy, because that was the same thing we did. We had 500,000 copies of Maya, the animation software, in schools around the world. In one school year, there were 500,000 people learning how to animate that way, and they went into the workplace and said, "Hey, I need my Maya." And so that's and it was a revolution at that time. So I get that.
Right.
I want to shift a little bit to there's a COVID has created a bunch of ripples, tsunamis in some cases and ripples in others.
Right.
And we've
Right.
been talking about that on the show for a long time. One of the things is because all the factories were closed for such a long time and they're still at limited capacity, there's a global semiconductor shortage out there. And so people, when they saw you were going to be on, we kind of wanted to hear your take on that. And not like you're in charge of solving that, but do you have a point of view on that? Because it's amazing how that has rippled through everything because semiconductors are in everything.
Yeah, I think, I'm still tied to the main legacy PCB manufacturing industry. And we are seeing those trends now where people see these global supply chain disruptions because I mentioned that whole process where now contract manufacturers are doing these builds. And so over time, the West has pretty much moved those kind of contract manufacturers over towards the East purely on dollars. And now we're finding that's not the most sustainable process for these global supply chains. And technologies like we're working on is print on demand. And you can have distributed networks when you have these kind of printers, or not just electronics that we're talking about, like regular 3D printing. If you look, there were some announcements today about other organizations pairing together to have distributed networks of printers, and you just start having these printers throughout the world. They all have the same capability practically, right? And now you can print and you can load up these machines and print things at the place they need to be. No, this is again 3D anywhere. And so I think that starts to remove these supply chain disruptions. But also when you think about these electronics, right? The base materials are a piece of laminate or a dielectric for those that are more engineering here, which is really glass and a bunch of epoxy. Think of it as epoxy. Yep. With copper on the top and copper on the bottom. We don't start with that, but everywhere else does. So now the supply chain is actually all the way back to the mines, the copper mines, and the resin systems, and building up that supply chain. Then that starts fighting with the big batteries that are now going to many electronic cars, and it's the same copper, and so you start fighting there, and so the supply chain starts going over there because that's where demand's at, and so it's like self-fulfilling prophecies that start to happen. And then you move it to the supply chain of the manufacturers that are manufacturing it, but then they have entire equipment. I mean, if you go to a PCB manufacturing plant, anything that's doing decent volume, the football field's long of equipment. And so you have the entire supply chain. So just to get that equipment in there, they, by the way, all have PCBs and microprocessors inside of them that can be delayed. And so when you have these concepts like we're working on, I think of it as like the penultimate lean solution. I used to sit in front of equipment and say, how do you remove this process? Well, this is boom, boom, the entire thing out. And you can put this one machine that accomplishes an entire factory of football fields long. In one place. And so I think that actually it's about that. It's not just like the supply chain from the east to west. It's about the entire supply chains that support just the manufacturing and the material operations that you're able to move with electronic printing as well as 3D printing as well, in metals and things like that, but just more smaller supply chains for sure.
I have a quick question. It feels like there have been some silver linings in the last year and a half. The pandemic has got us to look around corners, to think differently, to be, creativity craves constraint, all of those things. Do you feel like this is kind of the right time for you guys to be talking about this massive disruption?
Yeah. So I've been here almost 2 months to the date. Again, I had been in the industry beforehand, and I will tell you that I've had 3 very high-end customers, people know the names of, come back and say, we looked at your technology in 2016, 2017. We don't think we wanted to engage it then. And those very same customers are coming back on the same piece of equipment saying, you know what, we're here now to talk about it. And by the way, let's invest in the long term here, because I think they're seeing that. I think almost, if you probably look, I'm sure there will be tons of books on this in the future. The amount of money that has been disrupted because of all this is probably not the entire savings that every single person, particularly in the US, was trying to save by moving manufacturing over to the East. I think it is now a net neutral deal, and something that they're trying to fix. So I think they're trying to get forward looking on that and control those things in house. And by the way, you get a bunch of IP protection that happens with that as well.
I think that there are going to be plenty of books written about all the various things, the way that people have pivoted in a very, very, very interesting way. What's the next 5 years look like? Get your crystal ball out
Yeah.
for me for a second.
Yeah. So again, it's this revolution of the supply chain. So it's about that education to get those engineers 5 years into a company. It's working with original equipment manufacturers. Not just I can't get the demand into the manufacturers themselves, because again, they don't have a demand from a creativity perspective from the designers. So it's really forming those relationships with the OEMs in order to create that demand. But then it's really, what do those OEMs need 5 years from now, so that our design iterations of our equipment are starting to line up there. But it's really getting this concept of AME is not my company's thing. It's this new amorphous concept of a blob of material again in the world. So it's about making that a thing where you have to create standards around it, so that people have reliability, right? Because these things will eventually go inside of airplanes and things like that. And I think we all want to have that assurance that these things are fully tested. And so you have to create this entire ecosystem to support this revolution and get outside that wheel. And so it's about those long-term strategic deals with these companies in order to get the concept of additively manufactured electronics out there as a whole. So we want to be like industry leaders there, not just to sell equipment, but to revolutionize the supply chain and get those educational universities thinking about it and talking to get engineers to think differently about their design, and solving problems that we never thought we could solve before, because we were constrained by the design tools that we've had.
Well, everything I've heard about you and the company gives me great faith that you guys will solve those problems, which is just, I can't wait to tune in 5 years.
Look forward to it, Mark.